So hey guys, welcome to the channel Learning Competitive Programming with CodeChef. So if you want to learn data structures and algorithms and master competitive programming, this is the one-stop destination for you. Every week we will be posting several videos on CodeChef problems as well as various programming paradigms. So before moving forward, one small request for you. If you are new to the channel, then please do subscribe the channel and turn on the bell notification. Okay, so the problem that we are considering today is IPL, that is from ZCO 2014. The problem code is ZCO14004. The difficulty level of the problem is CAKEWALK and the prerequisites of the problem is basics of dynamic programming. So if you know something about dynamic programming, that will eventually help in solving the problem. But if you don't know about dynamic programming, then look at the video completely to understand the concept as well as the method that we are using to solve this problem. Okay, so today we are seeing the problem, that is the problem from the Zonal Computing Olympiad ZCO 2014, and the name of the problem is IPL. So I'll quickly summarize you about the problem statement. Okay, so we are considering an IPL season 2025, and in that season there is a rotation policy. So what that policy states is that a player cannot play 3 consecutive matches in a row. Alright, so Nikhil is the captain of the team and he chooses his team. So he wants to allocate himself such that he does not violate this policy, right? So he cannot play 3 matches in a row. And what we have been given is, we have been given an integer n and the fixed fees of a particular match. So we have been given an integer n, and for n matches we have been allocated some fees. So Nikhil wants to allocate himself such that he can get the maximum earning through this IPL season. Alright, so this is basically what the problem is. And let's now see the input format. So input format is a single digit n, which denotes the number of games in the IPL season. And for each match, what we have been given is the fees that is given on that particular match. The output will be the maximum amount Nikhil can earn from this IPL season. Right. So let's try out some examples to understand this problem clearly. That let us suppose in the input 1, what do we have? We have 5 number of matches, and for each matches this is the fees that is given to him. So what can be the maximum fees that he can draw from this IPL season? That is, if we take first 2 values and then he sums up this, that is 13, and now he rejects this day, he does not play this day, and then he quickly jumps over this value, right? So that will be 10 plus 3 plus 7, and then he can take this value as well. So in this particular example there is no consecutiveness of 3 elements, we can see. So these 2 elements are selected first, and then he removes this so that the consecutiveness of 3 elements does not happen, and then he select these 2 elements. So there is no consecutiveness of 3 elements, and the maximum earning that he can draw is 23, right, by summing up these values. Okay, so now let us take example number 2. So example number 2 have 8 matches, and for each match he has been allotted this fees, right? So now we can see what we can do is, he first select this match, that is the match 1, and gets the fees 3. Then he skips the match 2 and directly move towards the match 3, and for this match he is also getting the same amount, that is 3. And now he skips the match 4 and then he directly move towards the match 5, that is this match, and takes the fees 3 again. And now without skipping any further, he takes this match and gets the fees 5, right? So till now we have consecutiveness of only 2 elements, that is these 2 elements. And then he skips this match and then he get this match, and then the whole fees of the season will be 3 plus 3 plus 3 plus 5 plus 3, that is equal to 17. So this is the sample case 2. Now what is the testing data? What is the constraints that we have been given? So the n ranges from 1 to 2 into 10 to the power 5, right? So the value of n could be from 1 to 2 into 10 to the power 5, and the fees of the match, the value of the match, the amount that is given to Nikhil, can range from 0 to 10 to the power 4, both inclusive. Alright, so this is about the problem statement that we have been given. So the agenda for today is to understand the concept of dynamic programming. So first what we'll do, we'll get the basic introduction about dynamic programming. The second one is, we'll make some observations from the problem. And the third and the most important step is that we generate the DP formula from these observations. So this is today the agenda or the table of contents. So let's first start with the dynamic programming. So these are the three important points which are the pillars of dynamic programming. So the first point is divide a big problem to smaller sub problems, right? So if we have a big problem, that what do we do in dynamic programming? That we divide it into small sub problems. And then in the second step, what we do, we compute the answer of all the smaller sub problems and store it. So if we divide the problem into these smaller sub problems, then we compute the answer of these smaller sub problems and then we'll store it somewhere. And from these stored answer, what we'll do, we'll try to generate the answer of the bigger sub problems, right? So we'll try to get the answer of these bigger sub problems from these stored answer, and eventually it will help us to find the answer of the main problem that we are just encountering, right? So this is the basics of dynamic programming, and let's see how we can implement dynamic programming in this question. Okay, so the first step of approaching the DP problem is to make the observations from the problem, right? So the first and the important step is that we need to note down the observations from the problem. So the first observation is that we cannot take three consecutive numbers. This is the important thing, right? So we cannot have the consecutiveness of three numbers. So the question arises that how we should take the numbers. Alright, so let's analyze with the help of an example that how we can take the numbers. Suppose we have an array of length 3 and the values are 5, 7, 3. So if we want to find the maximum out of this array such that we do not violate the condition, then what we can do? We can first take these two values. Alright, so if we take these two values, then the answer must be 12. Right, so why are taking these two values? Because we cannot have these three values at a time, because it will create the consecutiveness of three elements, right? So I'm taking these two values, and one possible case could be the answer could be 12. If we consider the second case, then we can take these two values as well, because these does not violate the condition. So the answer in this particular case will be 7 plus 3, that is equal to 10. And there's one more possible case left. If we take the first and the last value, that is 5 and 3, and we will not take the 7, because if we take 7, then it will create a consecutiveness of three elements. So if we take the first and the last value, then the answer will be 8, and hence we are over with all the possible condition. That is, we have only three possible conditions, that is taking the first two values, the last two values, and the first and the third value in this particular example, right? So the maximum out of this is 12, that is from the first and the second value. So this will be the possible answer for this particular case. So this is the basic approach that we can think of while solving a problem. So what we can do while approaching a DP problem, first think of the smallest sub problem that it can have and analyze that problem. And after that, we can start building up the solution for the bigger sub problems, and finally we'll reach our answer. So this is the step-by-step process of how to approach a DP problem. Okay guys, so now let's start building up the DP formula. So here we are considering this is the array and this is the DP array. So what is DP array storing? As we have discussed in the introduction, that what is DP? DP is finding the answer of some bigger sub problems from the smaller sub problems. So here we are dealing with the smaller subarrays, and then we want to find the answer of the bigger subarray. Alright, so this is the common approach in DP, that we store the answer of the prefixes of that array in some array, and then we find the answer of some larger prefixes. Right. So here we are considering that at the ith position, the optimal answer till the ith position is stored in DP of I. So if we are considering these 4 days, right, these 4 days if we are considering, then the answer of this prefix is stored here. Alright, so for these 3, the answer is stored here, for these 2, the answer is stored here, and for this, the answer is stored here. Alright, so we have discussed the base conditions, that how we are filling up the base conditions, and now for any position I, DP of I store the optimal answer. But the game is that how we can calculate DP of I. Alright, So the first point is that if we want to include the ith element or not, right? So dp of I stores the optimal answer, but it does not tell us about the ith element, that whether we are including this or not. So that's the decision that we need to make. All right, so the first point is that if we are not including the ith element, then our optimal answer must be stored at dp of I minus 1. Why? Because dp of I minus 1 stores the answer that what is the optimal dp till the I minus 1 elements, right? So what is the optimal answer that we are getting if we are considering I minus 1 elements? And we are doing here in case number 1 that we are not considering the ith element. So if we are not considering this element, then the optimal answer till the I minus 1 would be copied. So this is one possible condition. All right. Now, since we have 12 at position I minus 1 in the dp, so one possible case that at position I we can have answer 12. That is one possible case. It's not the answer, it's only one possible case. Case number 2, if we consider both of these things. Now what we are doing at case number 1, we have not considered this element, but in case 2 what we can do, we'll consider this element. That boils down a solution into two approaches, right? So if we consider this element, then we'll take this element or not, right? So because it forms the consecutiveness of only two elements, right? So our solution boils down that if we take this element, then we should take this element or not. So case number 2 says that we should take this element. So if we are taking this element, then we cannot add this element plus dp of I minus 1. Why? Because dp of I minus 1, we know that it will store the optimal answer till the position I minus 1. So it may include position I minus 2, right? So if it includes position I minus 2, then it can form consecutiveness of these three elements. But that we don't want in this solution. We don't want the consecutiveness of three elements, right? So we cannot just add this array of I plus dp of I minus 1 as one of the cases. So what we will do then? So we'll do that, we'll add these two elements separately and we'll consider the optimal answer stored at position I minus 3. Why? Because I minus 3 removes the consecutiveness of this element, that is the third element. Basically, what do we want? We want that we should not have the consecutiveness of three elements. So we'll add these two elements, and then what we can do, we'll use the answer that is stored at position 0 of this dp array, so that we can get the optimal answer till here, and after that we remove this element and sum these two elements. So that can be one possible condition. And the third important point is that if we are not considering this element, right? So if we are not considering this element, then we can sum this element with the optimal answer that is stored at position I minus 2. Why? Because the optimal answer stored at position I minus 2 stores the optimal result till this, and the only thing we need to do is that we need to ignore this element so that we can remove the consecutiveness of three elements. All right, so the optimal answer till here is stored at this position, and we'll add this array of I element to this to get one possible case, as it removes the possibility of adding this element so that we can have consecutiveness in the whole array, right? So this possibility is removed when we consider this element and the optimal answer stored at position I minus 2, right? So I think these three cases are only possible to remove the consecutiveness of three elements, right? So I'll quickly summarize what we have just done till now. We have considered three cases. The first case is that if we don't want to include the ith element, in that our optimal answer must be stored at dp of I minus 1. This is the first case. And the second case is where we are including the ith element and I minus 1th element, right? So if we are including ith and I minus 1th element, then our answer boils down to the situation where we'll consider the dp at I minus 3, because we want to ignore the value at array of I minus 2, right? And the third and the last case is that if we are considering the value that is array of I and dp at I minus 2, because we are ignoring the value that is at array of I minus 1 to remove the consecutiveness of 3 elements. Then we'll sum up the values, that is array of I and dp of I minus 2, to generate one possible case, and rest there is no case possible to build the dp to find the optimal answer at the ith position. So what do we do next? To find the maximum answer, see that which values is maximum. So here in this case 20 is maximum, so we'll store the answer at dp of I, that is 20, and similarly we'll build the whole array. Alright, so now we can see at the end of this array the dp of n stores our optimal answer for the whole array. So what are we doing in this construction of dp formula? That we are finding the answer of the prefixes, that this value stores the answer till position this, 10 stores the answer at till position 2, 12 stores the answer till position 3, and this, the last part of this dp array, stores the answer till position 6, that is the whole array. So that is what we are doing, and that is how we are building up the dp formula. So this is the important thing. Some of the questions arise that how we are applying dp, how this formula is generated. So this is the conceptual theory, this is the process of thinking that how we can build the dp formula. So this is the final dp formula that will be formed after considering all the three cases. So sum, the optimal sum at any position I, will be the maximum of all the three conditions that we have just discussed. So the first condition, in which we are not taking the ith value, that is we are only taking the sum till I minus 1 position, is this. The second condition, in which we are considering the array of ith value and the optimal sum calculated at position I minus 2. The third condition, in which we are summing up the values of array of I and array of I minus 1, and we are taking the optimal sum till position I minus 3. So this is the whole dp formula of all the three conditions that we have just discussed. Now we'll look at the code of this problem. Okay, so now quickly see that how we can code the solution in C++ of this particular problem. So we have seen the concept, we have seen that how we are building up the dp formula, how we are setting up the base conditions, but the time is now to quickly implement this code, right? So first what we are doing is, in the main condition I am inputting the integer n and I am getting the values in this particular array. Now the better practice is to make a function of all the computation that we require in this question and simply output in the main function, because if we write the whole code in the main function, it just muggles up our whole logic. So what we can do, we can write a function naming fun and just pass the array and an integer n. Alright, so let's see what this function is doing. So this function is getting the arguments as the array and an integer value n. Now what we are doing is we are making a sum array, that is the dp array that we wanted in our solution, right? So this sum array is storing the maximum optimal value that I can get till position I, right? So first what we need to do, as we have discussed it in the example number 1, that we need to set up the base conditions, right? So the first condition is, if n is greater than equal to 1, then sum of 0 will be equal to array of 0. Alright, so if n has only one single element, then what will be the answer? That particular element only, right? So we'll fill sum of 0 as array of 0. So why I use greater than equal to 1 here? Because if I use the condition n equals 1, then it will only fill the value when the value of n is 1. It will not fill the value when the value of n is greater than 1, right? So I need to use n greater than equal to 1 to fill the value, that is sum of 0 equals to array of 0. Now if n is greater than equal to 2, then what I have considered the case, we'll sum up the two values, because till now we have not encountered any case where there is a consecutiveness of 3 elements, right? So if n is greater than equal to 2, we'll sum up the two values that we have just encountered, that is array of 0 and array of 1. So we'll add these two values and store it in sum of 1, right? And now if n is greater than equal to 3, so we have considered the case in which we'll take the three sums, that is first and second element, second and third element, and the first and third element. So that's all what we are doing here. So we'll take the sum of first and second element. So the first and second element sum is already stored at sum of 1. We have just stored it now, so we are reusing that value again. Now the sum of the second and third element is at position array 1 plus array 2. Consider this point very carefully, that the array has zero based indexing. So when I am referring to array of 1, that means I am referring to the second element in the array, and when I am referring to array 2, that means I am referring to the third element in the array. This is quite basics of C++, right? So array of 1 plus array of 2 sums the second and the third value, and array at 0 plus array at second sums the first and the third value. So the maximum out of this will be stored at position sum 2, that is the third value of the DP, right? The DP array. Now this is the computation of the formula from I equals to 3 till I less than n I plus plus. What I am doing is I am computing the formula that we just formed now and analyze the whole formula. So I am just using that formula once again, and then what I will do, I will return the last position of that particular sum array. That will be the maximum answer for the whole array, right? So the indexing is n minus 1 because I am using zero based indexing. So I'll return n minus 1th element of this whole array. So this is the formulation of the code for this problem. So now we'll submit the solution on CodeChef, language C++, and submit. So now we got the perfection sign, that is AC.